Hey guys, welcome back to my YouTube channel, Stephen Note, and in this video, I'm going to share with you my learning summary of Go Redis, a Redis client library written in Go programming language. In this video, I will show you the flow, how this client handle our requests. So without further ado, let's get started. Okay, so in this example, I have a Redis cluster with 3 master nodes and then 1 replica each. So in total, I have 6 nodes. And below these master nodes, there is a range of number. They represents a slot range. I'll show you about that a bit more later. And then this is the cluster client. When we initialize the clients, it does not actually make a connections to the clusters. It's just preparing the default configurations and default objects. The clients has or hold these 4 components. One is the cluster state, second is command informations, third is the cluster's informations, and the fourth one is the process managers. So cluster state is the informations about the clusters. It consists of the cluster's nodes itself, and then it has the list of master nodes, slave nodes, and also about slot informations in the cluster. And the cluster node itself consists of list of addresses that we specified in the beginning. It has list of active addresses that it's discovered eventually when the application runs. And then the third one is the map of active nodes in the clusters. And command info cache is basically a cache of list of all supported commands in the Redis. And process managers is the flow to process the command. The flow is different for each command types. It's different if we call individual command like get, set, hset, and stuff like that. It also differs with the pipeline and transaction pipeline commands. In this video, I will focus on individual command. When we set a command, in this case an individual command, there are 4 steps. The first step is to calculate the slot. The second step is to choose the node. The third step is to send and receive the response. And the fourth step is about error handling and retry logics. So let's start exploring about slot calculations. All right, let's talk about slot calculations. Slot is partitioning mechanism used in Redis cluster to distribute keys among multiple nodes. Redis cluster use hash slots to determine where the key is stored. Hash slot range. Redis cluster defines 60,384 hash slots numbered from this range. Every key we stored in the cluster is assigned to one of these slots using a hashing algorithm. And this is the hash algorithm. So for example, if we send get with this key user123, user123 is the key, and the hash slot result will be 12,893. With these informations, now we know that for this request, master tree should responsible for managing this slot because of this range, right? Or the replica, right? It can be the masters or it can be the replicas. What happens if we send a request with hashtag key. It's the same. We use the hashtag key, in this case 1000, to compute the slot, and the result is 11,326. What happened with the commands that the slot already specified? In this case, we just need to use the specified slot in the command arguments. And how about a command that doesn't need a slot? For example, ping. For ping, we can just use random slot because it does not really matter. So after computing the slots, now we know which of collections of nodes should responsible for that slots. So the next step is to choose which node should we choose to send the request. Okay, so the next step is to choose which node should handle the request. In this step, there are two main steps. The first one is to get the cluster state, and second, to choose the nodes itself. The get cluster state is a functions to get the informations of the current clusters. That includes the list of the nodes that's available in the clusters. And then after we have all the lists, we can put those nodes into the selection algorithms. So the next will be exploring how the client's library get the cluster state. All right, cluster stateholder has functions called get state. So how does it work? So it starts by checking a cast. If the state is not in the cast, then it will fetch a new one and then return the fresh state. If it exists in the cast, then it will use the stored state and return the case state. But if the cast state is older than 10 seconds, it will reload the state in different thread. So it's a background job. And then at that time, it will return a stale state. So now let's check how does reload state works. So it starts by getting list of node addresses. The client can get this from the initial address that we set or from the active addresses that the client discovered along the way. It will prioritize the active addresses. And then it will randomly choose the address to avoid hotspot by selecting the same address. And then it will try to get or create the object of the node, which is I will explain about it later. And then after the get the node object, it will run the cluster slots command with that address. This command will return the slots informations from the clusters. And then will return also what nodes responsible for each of the slots. So this process comes with some kind of retry mechanisms. And eventually, the cluster state will be created using create new cluster state and then return it. But if there is no active address, then it will just terminate the process. Now let's check about cluster nodes, get or create node. It's called by get or create node because it's cached in the memory. So now we have the node address from the previous step, we will check if that object is available in the cast. If yes, it will just return it. If no, it will create a new node object, which consists of the connection pool to that address or to that Redis server. And after that, there is a logic called root by latency. This logic is disabled by default. So let's assume this logic is disabled. So the new node will be saved in the cache and return it. So this node can be used to call the commands. And then what happened if the root by latency is enabled? And what is root by latency? So we will check about it in the next section. Okay, so what is root by latency? It is options that we can enable to choose the node by the closest node. Closest mean node with the lowest or the lowest latency. So the update latency functions is basically to ping that node 10 times with some jitter value. And if there is at least one successful ping, it will calculate the average of the latency. Let's say from 10 times it succeeded 5 times. Then it will calculate the average of the latency from that 5 tries. And then save the latency value. If there is no successful ping, then we will set, or it will set, an arbitrarily high latency. So this node will be deprioritized in the later stage when we selecting the node. So that is the update latency flow. Okay, so that is the get or create node flow. Now let's explore about create new cluster state flow. So at the end of this flow, the client will know everything it needs to know about the cluster states. If you remember, cluster states consist of list of master nodes, slave nodes, and then about the slot informations and all active nodes. So what it does, it will generate a timestamp, or not actually a timestamp, it's a counter. It's a monotonic counter called generations. I'll tell you about these functions later. And then it will get all of the slots, loop over it, and loop over the nodes corresponds to that slots, and then get the nodes, and then set node generation, which is I will share with you later, and then group the nodes by the type like master or slaves, and then do all of these until at the end of the slots, and then we will have the cluster states. And then if you see at the end of the flow, there is a schedule to run node garbage collections after 1 minute. So what are these generations and GC does? So whenever we execute new cluster state, there is a monotonic counter called generations. We'll increase the counter by 1. For the first time, the counter will be 1. At time A, for example, in the cluster state, there are 3 active nodes. Node 1, node 2, and node 3. So for each of these nodes, it will have the counter of 1. Okay? And when the GC runs, the GC will check if there is a node that less than the latest node then the GC will remove, or otherwise it will keep. In this example, all of the 3 nodes have the latest generation counter of 1. So it keeps all of the 3 nodes from the cluster state. And then after the first run, let's say at time B, master node 3 is replaced by master node 4 in the Redis servers. So what the client does, it will increase the counter. So now the counter is 2. And then for each of active nodes, it will assign by the latest counter, which is 2. But for master node 3, because this is not an active node, the counter will remain 1. And then when the GC runs, because the node 3 counter is still 1, the node will be removed from the cluster state and the connections will be closed. So at that time, the clients will understand that in the clusters, the master node 3 has been replaced by master node 4. So this is the explanations of the generations functions. Okay, after we understand how the client can get the state, now it's time to understand how the client choose the node from the informations we get from the cluster state. So there is a config called read only. This config is disabled by default. When enabled, the client will try to redirect a read-only commands to the replications nodes if possible. If this config is disabled, any read or write commands will go to master node. So if the read-only configuration is enabled, then it will run get command info cast. What this command does is basically select 3 random nodes from the list of node addresses and then run command called command. This command will result every supported Redis commands available and save it to the cache. At this point, the client will now have enough understanding and then can differentiate which commands is a read-only and which command is a write-only command. If command is read-only, then it will trigger get read-only node. If command is not read-only, it will trigger or it will use the master nodes. In the next session, we will see all of the options to get a read-only node. So at the time of recording, the client has 3 options to choose read-only node. First is by closest node, second is by random node, and the third one, which is the default options, is to use slave node. Let's uncover one by one. I have shared with you about root by latency before, right? So it's an options to choose the nearest node for the node selections. So if that option is enabled, then it will trigger slot close node. What will happen is from all the nodes that responsible for the given slot, it will try to get the healthy nodes with lowest latency. Healthy here means not failing. And then I will explain about failing nodes later. And then if there is node that is healthy, then it will choose it. So we will get the closest healthy node. But if there is, or if all of the nodes are failing, but at least there is one node with latency under 1 minute, we will choose that. So we will get closest failing node. But other than that, meaning if there is no nodes available for the slots, or all the failing nodes latency is over 1 minute, we will pick one random node. So at this point, probably you are confusing why the client pick a failing node as the failover. Let me explain about that in the following sections. So what is failing node? So to explain that, let's jump into the retry logic handle. Okay, I think it's okay. So as you can see here, there are this type of error that is retryable, right? And then for example, if the command response is a loading error, right? Or any of these error like master down, cluster down, try again, etc., etc., that node will be marked as failing node. This mark will be expired in 15 seconds. And after 15 seconds, this node can be chosen again in the logic, right? Because this is a temporary error, the client expects that this node will be self-healing. So it means the node is still there in the clusters, but we encounter with some retryable error from the last response. So as a failover, this mechanism is acceptable. Okay, now let's continue to our slot read-only node algorithm. So I have explained about slot closest node. The second option is by selecting the node randomly. This option by default is disabled. So what does slot random node does? Right. So it select a healthy node randomly, otherwise pick one unhealthy node. So it get all the nodes responsible for that slot. If there is no node responsible for that slot, it will pick one random node. If there is, but there is no slave, there is no replica, then just use the master node. If there is slaves, then we'll pick one random healthy node and return it. But if there is no healthy node, then we will select one random slave that is unhealthy. So that is the cluster state by random node. Okay, so the default options of the node selections is by using slot slave node. It's a flow to select a healthy slave node if available. If not available, use master node. So it begins by getting all nodes responsible for the slot. If not, if doesn't find, then it will pick a random node. But if there is a node, then it will check. If there is no slave, or if there is no healthy slave, then it picks the master node. If there is a healthy slave, then it will pick a random healthy slave node. So we will have the slave node. So that's the logic of slot slave node. So what is the main difference between slot random node and slot slave node? So I think the main difference is that in slot random node, if there is no healthy node, it will use random unhealthy node. But in slot slave node, if there is no healthy nodes, then it will use master nodes. So that is the main difference. So after the client knows which node should be chosen, now it can start sending the request and retrieving the response to the node. Right. So the logic begins by getting the connections from the pool. So remember, the connection pool is reside in the node object. If this is the first time, it means the connection has not been initialized. Then it will initialize the connections, like doing all of the authentications and setting up the options for the configurations. And then it will start the writer flow. What writer flows does, it will serialize the arguments from the commands to the Redis protocol and then send it via TCP. And eventually it will get the response and then parse the response using the Redis protocol so that we will get the response. So that is the reader logic. If there is no error, then the connections will be returned to the pool to be reused. If there is a connection, if there is an error, but the error is not the connection's bad error, the connection will also be returned to the pool. So I forget to add one more line here. But if there is a bad connections error, then the connection will be removed. So it won't be reused again. And eventually, it will check if the error is the type of error that can be retried. If it is, it will be retried by or from the beginning, from getting the connection pool. The highlights of this process is that eventually, if the error is context cancelled or context deadline exceeded, right? It's a part of bad connection error. It means that the connections will be removed. So if your applications set a very tight deadlines and then you observe a lot of deadline exceeded error, every time your application initialize the the request again, it will start from creating a new connection pool and start over the initialize connections process. So it can be an overhead for your applications. So what we can do if you see this is a problem is to create a custom, let's say, error handling in our applications that does not set the context deadline explicitly for this process. So therefore, the process can go on without the context deadline, where eventually it will be terminated by timeout configurations, not using context, but in the clients. So therefore, the connections can be reused for the other requests. So maybe for that explanation, it's more clear if I see the code example. but I think that is for another video. Alright, here we are at the last steps, which is error handling and retry logics. I only put retriable error here. Any error other than this is not retriable, including the context deadline exit or cancel. If there is a read-only errors, right, it is a retriable error. Okay, so read-only error can happen when we send a write command to replications. How comes it can happen? Let's say the role of the nodes is interchanged from master to role and to role to masters, right? So when that happens, the connections will be removed from the connection pool. So next time it can use the different nodes. So what happened is that when this happened, we will trigger the refresh cluster stats because we know that there is a role that has changed, right? So we need to know the latest cluster state. And then we need to reset the node. It means that to choose different node for the next retry. So when we retry for the second and following attempt, we'll pick a new node by following this flow. What happens there if there is a connection error? Well, we just simply reset the node or choosing the node or different node for the next retry. What happens if there is a loading error? It means that the node is in the state of loading the data into shard. In this case, we will mark the node as failing and reset the node for the next attempt. What happens if there is a move or ask error? It means that the slot that we send is not managed by that node anymore. It's being moved to another node that is moved. Or ask means that nodes ask us to temporarily change the node because it's in the process of resharding, right? In that case, we need to refresh the cluster states so we will know the latest slot information as well and the latest nodes informations. And then we'll trigger the get or create nodes for the redirect address because from the error we will know the new address and then we use that address to get or create the new object of the node to be reused for the next attempt. And then for any of these error, master down, cluster down, try again, error pull timeout, or when we reach a maximum allowed clients or EOF errors, we will simply mark the nodes as failing and reset the nodes for the next attempts. So that is the last steps of the flow. Okay, that's the end of the video. I will try to summarize. So by learning this, now we knows what the library does behind the scenes. So if there is particular issue that you feel is not part of your code or it's not part of your cluster setup, you can try to debug the library. Maybe there is an issue with the library. And second, by checking the codes, I discover new techniques in terms of, let's say, guarding the data from that data racing. And then interesting technique in terms of managing the cluster state and stuffs. So yeah, I mean, reading the codes from OSS repository, there is always a new things to learn. So I hope you enjoy the video. Until the next video, keep learning and stay healthy. Bye bye.